All right, this is section 6.2, which is representations of functions. We're going to start with the key idea, which is our first representation of a function, which is an equation. Okay, so they're going to end up being 5 ways we can represent functions, and equations is one of them. So a function rule is an equation that describes the relationship between inputs, which are known as your independent variable or your x, and outputs, which are your dependent variables or your y's. Okay, so we like to think of this function machine. Whatever you input to the function, remember inputs are x, whatever you input to your function, it goes through the function rule. So this is y equals 3x. So this would be 3 times -2 because you inputted -2. And then the output is -6 because 3 times -2 is -6. So that's kind of like how a function rule works. Whatever number you put in the machine, it does the rule and spits you out an answer. Okay? You need to be able to write function rules. Example 1 says write a function rule for the output, and I like to underline things as I go. So the output, which is y, is 5 less than is a subtraction problem, the input. Okay, so the output is means equals in math. Okay, so the output is 5 less than the input. Now, less than is a tricky one to start on because usually you can just go in the order that you see, but in order to take less than something, you need to know what you started with. Okay, so the 5 and the x kind of need to switch places on this, and it would be x minus 5. So let's look at this. The output, y, is equals 5 less than the input. And we have completed part A. Part B says the output, once again, output is y, is equals the square of the input. Okay, the square, remember, means something squared. If you're squaring something, you're multiplying it by itself. So this is the output is the square of the input. So y equals x squared. Here are 2 more ways to represent a function: mapping diagram and ordered pairs. Are 2 more ways to write a function. So writing a function rule for part C, you would say, well, first of all, you kind of have to look at the pattern. So we go from 1 to 2, we go from 3 to 6, we go from 5 to 10, and 7 to 14. So I notice that I am taking the input and I am multiplying everything by 2. Okay, so I would say the output is equal to the input times 2. So the output, which is y, is equal to the input, which is x, multiplied by 2. Now, we don't really write it x times 2. The actual correct way to write that would be y equals 2x. But as you're kind of sounding it out, it's totally fine to write it this way and change it to our final version later. Okay? So let's look at the mapping diagram. I go from 10 to 14, from 20 to 24, from 30 to 34, and 40 to 44. You can clearly see the input plus 4 is equal to the output. You can totally write it in that order as well. So you could say the input plus 4 is equal to the output. Now, if you're like me and you like writing y first, you can totally change it around when you're done. Either way works. All right, the next type of problem is you need to be able to evaluate a function when we give you a given variable. And in this case, we give you x. So we give you x is equal to 3, and all you're going to do is plug it in for the x in the equation. Okay, so I'm going to write my original problem, y equals 2x plus 5, and I'm going to plug in 3. It's kind of like substitution. So I have y equals 2 times 3 plus 5. 2 times 3 is 6. 6 plus 5 gives you 11. So what is the value of y equals 2x plus 5 when x is equal to 3? Your answer is y is equal to 11. Okay, you have 3 on your own problems to do. You need to write a function rule, and then you need to evaluate these 3 problems when x is 5. So you were going to plug in 5 for all the places that I highlighted, and you are going to solve for y on those on your own problems. So hit pause, do that, and when you're ready, you may continue on. All right, 2 more ways to represent a function is a table and a graph. Okay, so a function can be represented by an input-output table and also by a graph. And both of these representations are the function y equals x plus 2. So think about this. Y equals x plus 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. And then x plus 2, my y-intercept is 2. My slope is 1. So you can see that both of those represent the same function. So by drawing a line through the points, you graph all of the solutions of the function y equals x plus 2. So there are more solutions in here that I have not listed. And by drawing a line, you show the reader of the graph that there are multiple solutions to that function. And lastly, example 3, we're just going to graph this function. This is going to seem very, very, very similar to chapter 4 because we have done this so far this year. So we're going to graph the function y equals negative 2x plus 1 using inputs of negative 1, 0, 1, and 2. Remember, inputs are x, so I'm going to make my table. My x's are going to be negative 1, 0, 1, and 2. My function, I'm going to write here in the center so I have room to show my work, is y equals negative 2x plus 1. I'm going to get my output, and then my ordered pair I'm going to write in this column, okay? So y equals negative 2. I'm going to plug in negative 1 plus 1. Negative 2, times negative 1 is positive 2. 2 plus 1 is 3. So this is the point negative 1, 3, x comma y. Plugging it in 0. Negative 2 times 0 plus 1. Anything. I keep hitting that button, so sorry. Negative 2 times 0 is 0. 0 plus 1 is 1. So this is the point 0, 1. Y equals negative 2 times 1 plus 1. Negative 2 times 1 is negative 2 plus 1 is negative 1. So this is the point 1, negative 1. And lastly, negative 2 times 2 is negative 4 plus 1 is negative 3. So this is the point 2, negative 3. Once you have these points, you are ready to plot them on your graph. So negative 1, 3 is over 1 up 3. 0, 1 is right there. 1, negative 1. And 2, negative 3 is down there. Plot the ordered pairs, draw a line through all the points showing your solution, and you have done it. Now, you're probably thinking as we did that long drawn out table, there is a way easier way to graph, and you are absolutely correct. So you may graph these using your M and your B if you would like to, because I didn't give you room for a table. So what I mean by that, I'll do number 7, 3x plus 2. Remember, you can start at your y-intercept, and you can rise and run to get your other points. So my slope was 3, so I was rising 3 over 1. You may use that strategy for both 5 and 6. Example, this is a real life application. So the number of pounds of carbon dioxide, that's probably important, and the number of pounds P of carbon dioxide produced by a car is 20 times the number of G gallons of gasoline used by the car. So the number of pounds of carbon dioxide, I'm going to call that P when I'm writing my function. I'll write it up here so I save some room. So writing my function, P is, there's my is, which is equal. P is equal to 20 times the gallons of gas. So P is equal to 20 G, which would be my equation. Now, don't be thrown off by P and G. If you need to use Y and X, knock yourself out, okay? P and G just help you know what it's talking about in the context of the problem, okay? But really, they're the same thing. So making an input-output table, we need to pick our inputs because it didn't tell us. Let's just pick, well, we can't have a negative amount of gallons, so let's just start at 0. Let's do 0, 1, 2, and 3. So that's my inputs are my x. My function is y equals 20x, and then I need my y. So 20 times 0 is 0. 20 times 1 is 20. 20 times 2 is 40. And 20 times 3 is 60. Okay, so then we need to come over here and graph our graph. So your gallons of gas are going to go on the bottom because that is your x variable, and your carbon dioxide, doing really good at writing sideways on that one, and that's in pounds, is going to go on your y-axis, okay? So we need to label. Let's just go up everyone by 5s, but I'm only going to mark every other because you don't have to mark every single thing. And I need to get up to 60. So there's my 60. And then, I don't know, count by whatever you think over here. Only need to get up to 3. Okay, so my first point is 0, 0. My second point is 120. My third point is 240. And my fourth point is 360. Once again, it should be a straight line. All right, so once again, the 5 ways to represent a function. You can have a word phrase, you can have an equation, you can have an input-output table, you can have a mapping diagram, you can have a graph. I would like to argue you could always also have ordered pairs. We could add to that list, but you need to be familiar with all 5 of these ways to represent a function. Have a great day.